Hello students! For those of you who are interested as an extension, in this video we are going to see how we can numerically say whether a function fits well your data points or not. Of course, you can always see it visually. For instance, in this example, you can comment on how on the left hand side here your function does not really pass the data points. So it's already some kind of analysis on how well your formula actually fits the data. If you would like to see what formula we have entered the last time, you can always go back here on the top right corner and click this button and say View Algebra. So then the algebra window will show, and if you scroll up, then you can see the formula that we have entered the last time. So I'm going to make this window narrower and try to zoom in a little bit, or zoom out actually, so we can see our data and function a bit better. So what we will try to do now is to extend this spreadsheet. I'm going to make this a little narrower. This was the X variable, our number of days starting from a certain date, and this is the daylight length in hours. So I would like to enter here on this column the prediction by our function. So in this cell I will actually put what will be the calculated value that our function has if the X value is 0. So then I'm just going to say a formula on spreadsheet equals F, because our function was called F just now, and then in bracket I'll just enter the cell. So here is A2. So if you just click there in that cell, it will automatically take the value in the cell that we have just clicked. And if you press enter, this is a prediction by our function. So if you just copy that for all the rest of the data, you will get the prediction for every single X value we have in the data. And I'm not very sure how your file behaves, but in my case I have to actually go and do this copying one more time separately. Hopefully yours behave better, but anyway, now we have everything for all our data prediction. So you can see here sometimes my function predicts lower than what the data shows, and sometimes it's actually higher. So we are going to put in this next column how big is the error made by our function's calculation. So in this case, I'm just going to subtract the prediction, subtracted by the real data. So in this case, because the prediction is lower, then you get a negative value, but it's of course later on a positive value if the prediction is actually higher than the real data. So that's what we will just continue copying. All right, so I can't really say anything because sometimes it's higher, sometimes it's lower. So what we will do here in the next column, I'm just going to take the absolute value of the error. We'll call it absolute error, and that's what we'll do. We'll just take the absolute value. So equal, an absolute value function is ABS here in the spreadsheet formula, and I'll just say absolute value of each cell. So in this case it's D2. So you see it just takes a value without the negative sign, and I'll just do the same for all the rest of my data point. So again, I have to continue copying for the rest of the data at the bottom, and that's it. So everything now is positive, and this is basically how far away our function's prediction is from the real data. And if I'm going to now take the mean of all this value, I will have a value which is called a mean error. So at the moment what we have is the absolute error of every single x value, so every single days, number of days that we have. So how good is our function in general? We are just going to take the average of all those absolute error. So I'm just going to say here at the bottom equal mean, and I will just say the cell that we had just now is E2 and up to with the colon E25 is our last cell in that column. So if you close the bracket and press enter, you will get the average basically of all the absolute error value. So what does this value show us? It actually shows on average your function will predict this far away from the reality, from the real data, 0.48. In this case is 0.48 meter. Right, so what is the use of doing all this? You might think, oh, I can maybe improve my formula and try to make this left hand side a little nearer to the data points. So will that actually help to make my function better fit the real data? So we can try that, and you can see what happens later on to our mean absolute error. So let's say maybe we can try to bring this green graph a bit to the left. So think about what we should do for that. What should we do in the formula to bring our function a bit to the left? You can pause and think about it for a while. Alright, so I'm going to try that. So here what I will do is I'll just say, okay, I'm going to say do translation. Let's say I'm just going to do something, try something to the left 10 units or something. So see, be careful with where you place the degree symbol. So if I do so, what will happen? Check visually, and also what happens to our mean error. There. You can already see that visually it looks like your second function, when you did translation to the left 10 units, is fitting a little bit better. And you can also see that here the absolute mean error has also changed, and it is indeed lower. So which means it makes a slightly lower error than the previous function. So hopefully you get the idea, and if you would like to, as an extension, you can do something like this in your project. Good luck!